Welcome to the Heartbeat of Water. We're delighted to have you with us to learn about using data and machine learning to monitor flows and preempt leaks, bursts, and failures in our pipelines. Next. If you could. Why monitor the heartbeat of water? Depending on your location and the age of your infrastructure, leaking pipes are contributing to a 10 to 30% loss of water in current infrastructure. And as you'll see on this slide, the American Water Works Association, with their current magazine, has made that a focus with water audits, looking for opportunities to find non-revenue water and start to use it. The Plumbing Manufacturers International also has advocated for restoring our infrastructure and have identified in their infographic on the right-hand side, 850 water main breaks occur each day. More than 1.7 trillion gallons are lost to leaks, and that's about 16% of treated water going down the drain. On the left side of this page, I just want to point out the tremendous resources already available to many people who can be accessed today so that you can continue to learn. The EPA, the American Water Works Association, has put together a water loss control page and site, and also the Smart Water Networks has just started implementing a program to help across North America. They've been active in the UK, but they have technologies and the ability to utilize data, and some of what we're going to hear about in today's webinar. Next. In fact, there are many opportunities for data analysis in the water industry, and I was delighted to run across Danny Cordelis of Suez, sorry about that, who is implemented a variety of solutions or suggested how we can apply data to better manage networks and track our assets and understand the flows, the users of water, as well as the people who, the resources of water and where they stand, both quality and the quantity, and then customer service. Next. And it's a pleasure for me to introduce you to Shoshi Kaganovsky. She's the founder and CEO of SensOLeak, and she has 48 applications on 4 continents, predicting and diagnosing failures, including work with the U.S. Navy and the Los Angeles County's Public Works Department. And so, Shoshi, I'm going to turn this webinar over to you because you are the expert doing this, and we're eager to learn more about it.
Well, thank you, Mary. Thank you for the introduction. Welcome, everybody. Good morning, I assume. I'm based in Israel, and currently I'm in Israel. And just like Mary said, I'll be flying to Australia soon. The Israeli Prime Minister chose SensOLeak from more than 1,300 companies to accompany him on a formal visit to Australia. So we will be going there and presenting our solution to Australia for water, oil and gas, and the energy industry in general. So let me tell you a little bit about what we do. We have developed a statistical algorithm, which is a very scary word for software. We don't do any hardware, but we are able, with our algorithm, which is machine-based, machine learning-based, to determine small defects or deviations from the norm in all sorts of pipelines, as well as rotating equipment, like pumps, compressors, heat exchangers, wind turbines, anything with an engine. We rely on the data that's transmitted from the sensors and is stored in the SCADA. What we do, we determine the norm, the normal behavior of each and every pipeline or piece of equipment that's being monitored, and then being able to monitor it 24/7, our algorithm presents alerts about deviations from the norm. Currently, we are pretty much the only ones who are able to determine defects and stop leakages from happening, because we're actually able to see the escalation of the defect and stop it in advance, or alert the operators to act. And in terms of leakage detection, not just prevention, we are able to detect a leak the minute it starts. It could be as small as 3 drops. That's our best rate so far. So our technology started to develop in 2009. It actually started in monitoring helicopter engines, but we were looking for different applications, additional applications for preventive maintenance. I wouldn't say we're a leakage detection company per se. We're a big data company or analytics company, but we chose at the time to focus on the energy market, especially on pipelines, because we identified a real pain with no good solution out there that hurts not just the company and the pipeline operators, but also the environment. And we were trying to bring this technology to the energy market, so we were under R&D for about 5 years, and we're testing this and developing this and running this on different things, from wind turbines to underground activity detection, and it worked, knock on wood, 100% of the times. So we ran pilots and POC, proof of concept experiments, and it worked. Now, as I said, this software that we have developed is very easy to implement. It's a seamless solution. It's a plug-and-play solution. We only need to connect to the SCADA. And the algorithm we have, which is already patented, is not a shelf product. It's only the baseline on top of which we actually develop more statistical models and mathematical models. And in order to determine the normal behavior of any equipment, especially a pipeline, we need to take a lot into consideration. So usually we measure for the online operation pressure and flow. We look for correlations. One thing that differentiates us from other leakage detection or algorithm-based companies is that we are we're trying to explain one variable or changes in one factor by the others. And that's how we manage to clean the noise, and that's why we don't have any false alarms. False alarms cost a lot of money for the operators, especially in oil, but also in water, because they need to stop the line, start digging, or start looking for the location of the leak just to realize that there's no leak. And in terms of small leakages, it's also very difficult for existing systems to detect them, because the standard is about 15 minutes to identify a 50% leak, or if it's a smaller leak, then it's 48 hours or 72 hours or even more. So once we identify the health grade, the normal behavior, it just runs automatically, and once we finish the installation or connecting our system to the operator's SCADA, which is custom-made, we actually tailor-make all our solutions for each and every client according to what they have. So we first learn what kind of sensors they have, where they're scattered along the line, what's the transmission rates, and fix everything to work with their specific system, which works automatically. IoT or machine learning basically allows the algorithm to work by itself. No one actually has to stare at screens all day long or to be in the control room in order to be aware of a defect. The algorithm will provide the alert by itself. It could be a text message, a phone call, anything the operator wants. It's applicable to all sorts of pipelines, water mains, oil, gas, petrochemical plants, process piping, but we do not really work with municipal systems. Since we only have a software, we need to rely on existing hardware. And the thing is that municipal systems are so complicated, so there are so many branches that most of the times they are not equipped with sensors. So in order for us to work on municipal systems, we actually need to have them equipped with sensors, a lot of hardware, and start from the beginning. Main lines are very easy because they are already monitored, it's regulated, a lot of data is stored, and we can learn on historical data in order to establish the norm. Yeah, I think I went over all of these. It's an online monitoring system that actually identifies the defects that lead to leakages. And I will show you a bit later how it works. So as I said, a normal pipeline shall have sensors and transmission from the pipeline to the server or the control room or the SCADA, where the data is being analyzed, and according to this data, they can actually, and we can as well, determine whether there are changes in the pipeline or a leakage or other defects. So what we provide basically helps operators and integrity teams and maintenance teams to save a lot of money. First of all, we do not require them to make any changes, and when we implement our solution, we do not interfere with any processes, and we do not require anything. We do everything we can in order to fit well with what the client already has installed. The algorithm does not require any new hires or does not require any special PhDs to be in the control room or to be added to the company. We actually train the local personnel how to deal with the day-to-day operations. Since we don't require the customer to upload the data to our server or our cloud, it all stays in-house. We need to have some people understanding what they see, or to have a chain of command who gets an alert and when. Customers tell us that one thing that helped them save money after installing SensOLeak is insurance. The rate went down significantly because now they have a preventive measure. And the installation is pretty easy. Just imagine as if you were plugging a USB drive into your computer. Just imagine a box just being added to the server and runs automatically. So it's applicable to, as I told you, a lot of things because it has to do with big data. Anything that can be monitored, anything with a sensor is good for us, as long as it's as close as possible to real time, 24/7, or has enough data so that we can make sense out of it. We do not have any additional requirements. Sometimes we recommend that operators install additional hardware, maybe acoustic sensors or some other sort of sensors in specific areas, sensitive areas, politically sensitive, or residential areas, or close to water areas, especially in oil, because the damages are basically enormous when there's an oil spill next to a water source. And it's applicable to anything in the systems, not just the pipelines, but the pumps, and we provide also alerts about the sensors. We monitor everything. Whenever we see a change, a deviation from the norm, we alert. We are able to detect the location to definitely when there's a leak, we can pinpoint the exact location of the leak. When there's a defect before the leakage occurs, we are able to identify the location with an error of about 3 feet, which is not bad, and it's close enough to the leakage so it could be found easily. Right, so just to demonstrate on one case how it works, one more thing. Every time we approach a potential client or a client approaches us, we require or we request to run a POC, a proof of concept, some sort of a pilot. Oftentimes we'll learn from this pilot how the operator operates, how they collect data, what's the transmission rates, which kind of SCADA they use. An offline experiment, a POC, is basically analyzing a previous critical failure, a leak. So it's 2017, I would say I would ask a case from 2 or 3 years ago, and we request 2 sets of data. So one set of data should contain 3 months of normal behavior or as close to normal as possible, meaning data that does not contain leak or leakages, because this is for training. When we train the algorithm to recognize what's normal and it contains a leak, it will be trained, it will learn to recognize leakage as normality, which is not. And then we ask for the second set of data to be 3, 6, or 9 months, and contain a leak. We request not to have any information about the leak, not when, where, why. We want to analyze that and show by ourselves to the customer when the leak started, how much leaked, and how much in advance we could have actually alerted and prevented it had our system, had our algorithm been installed. So just a small case to demonstrate how it works. This is a water pipeline in the Netherlands, in Europe, about 37 miles in American measures. They had 3 leakage detection systems, and they had a leak in 2015 that was going on for 5 days. They had no idea they had a leak until a citizen called and actually asked them if he's going to pay for his new pool in his backyard. Now, of course, they came, they apologized, they sealed the leak. 2 days after that, we arrived, we showed them our solution, and like many others, they practically left us out of the room, saying this is science fiction, we are not Jesus, we cannot predict anything. So we told them, let's run an offline trial and we will prove it to you. We asked for 2 sets of data, 3 months of normal behavior, and let's say 6 months containing a leak. Now, the problem here is that every 2 weeks, someone would just delete all the transmission data from the sensors to make room in the server. And when we approached them, we were probably too late because they couldn't give us 3 months. They gave us only 8 days for training, which is very tricky and challenging, but we accepted the challenge. Worst case scenario, we would be wrong. So the upper chart right here, let me just enlarge it a bit. The y-axis indicates the flow, which was 8,000. The maximum flow in the pipeline was 8,500 cubic meters. Let's say it's 8,500 units. And the x-axis is time. Now, I'm not sure you can see that, but afterwards Mary will send it to you. There are green and blue dots all over here in the training stage, the upper chart. The blue are the real ones, the transmission rates that arrive from the SCADA, and the green is the estimated ones, meaning our algorithm. The fact that they overlap almost entirely means that we train the algorithm well. The only place it does not overlap is right here, but that's the leak. Now, let's see what we did for the testing. The lower chart is the testing. After we trained the algorithm, we started looking for the leakage or the critical failure. Now, the y-axis again is flow, but look what happens here. This is the leakage. And as you can see, it's on 80, meaning 1% out of the maximum flow inside the pipeline. And this is probably why they missed it, all 3 leakage detection systems they have, because it's a rather small leak. It ruined someone else's yard, but in terms of water companies, it's not that much. So in order to determine a defect and to differentiate it and to track it and to track its escalation, we have 2 thresholds. So the yellow threshold is basically the first one. We set it at 8, meaning 0.01% change. If 80 here was 1%, 8 would be even lower, even more sensitive. Everything below the yellow line is normal. Even though it fluctuates, it's okay. No pipeline behaves statically normally, ever. Above the yellow line but below the red line, it's the formation of the defect. It's where the problem starts. Everything above the red line is actually the critical failure or a leak. Now, the testing started after this dashed line on November 23rd. You don't really have to be a statistician or a big data scientist or to even understand how our technology works to see that this part from the 27th of November until December 9th, the leak, it's not normal. It goes above and below the yellow line, it fluctuates, and you can actually see it with your own eyes that something here is wrong. Up until December 9th, when the leakage starts and leaks for 80 cubic meters an hour for 5 days. Now, this is the prevention part. We actually identified the problem. We saw that this was inner corrosion, which is very easy for us to identify. Our algorithm is so sensitive, we can actually sense that the inner diameter of the pipeline is getting bigger. The corrosion eats the pipeline from the inside. It's a very slow process, and it's very difficult to detect because it eats very small amounts. But if we know the thickness of the wall of the pipe and we know how the corrosion progresses, we would be able to predict exactly where the leak would happen. But not just prediction, we would be able to show the operators that there's a defect that looks like inner corrosion due to the changes in the diameter, and alert in advance where it's happening and how much it's eating from the pipeline. This is the smaller version, but we can enhance each and every black dot here and to see a non-decreasing pattern that will present that the escalation is actually going and escalating and progressing until a leak forms. So not just leakage detection or safety measures, external factors, we call that. A lot of times people start digging or operating agricultural equipment or even stealing water, and no one knows about it until it's too late. With the help of all the sensors that are installed on the pipeline and the sensitivity of our algorithm, we're able to detect that something is going on externally around the pipe in the vicinity of 8 feet, with a radius of 8 feet from the pipe. I would not be able to know if it's someone digging or construction or a herd of cows is passing, but it's not that problematic as being wrong about an inner defect like corrosion. Because in terms of external factors, they can just pick up the phone and ask someone what is going on, or they don't really need to spend money and start digging or stop the line. In terms of inner escalations, inner defects, it's very difficult to determine, and even after a leakage starts, it's not as easy to identify the leak apparently, and a lot of false alarms still occur. So what we provide is this early alert about escalating defects. Since they gave us only 1 month, we only made this identification 2 weeks before the leakage started. On average, our rate in detecting a leak before it starts is 42 days. So it's a month and a half. And of course, the leakage is right here. So training stage, testing stage, and 2 thresholds, the sensitivity of which we determine together with the client. Some operators want to know as soon as a defect starts. Some want to have it escalate up until a certain point, which is okay. My job is to provide the alerts about a defect or an escalating problem. This is another case which I will just brief you quickly. An oil and gas operator in Israel, the largest one with 117 lines, was looking for a leakage detection company in 2013. Now they called us in and they told us that they checked about 24 leakage detection companies around the world, and they wanted to simulate a leak, a very small leak for us. So we arrived to their control room, we set up everything, and one of the valves was supposed to be on 0, no flow. They opened the valve either 2 or 8 degrees only. It was supposed to simulate 1 to 3 drops leaving the pipe. And no one else could identify this leak, so-called, even hours before they opened the valve. We identified it within 30 seconds. Why 30 seconds? Because this is the interval the transmission rates were coming in. So as I said before, we are looking for correlation of pressure and flow. So say if the pressure sensors transmit every 2 seconds, but flow sensors every 5 seconds, we would be looking for the common denominator, and we would be looking at the data every 10 seconds. So this data, pressure and flow, were coming in together every 30 seconds, and we managed to identify it immediately and alert. And also it was on a transient state, so they were very happy to see that. Apparently, we did not even know that at the time. We weren't pipeline people as much as we're statisticians and analytics. So apparently a transient state, unlike a steady state, is very turbulent and very problematic. and apparently our algorithm was able to overcome this turbulence or transient state problems. So water, oil, any pipeline, also factories, and basically we don't really mind what's flowing inside as long as it's monitored. Yeah, I'd be happy to answer questions. Let's see if someone wrote something. Nope. Okay. So
Yeah, no, we do have a few questions, Donnie, that came in before, actually before the webinar, and I just want to get your thoughts so people can interact with you. What's the best way for them to get in touch? Because your time, I know, is very limited as you're running around the globe helping people.
I'm basically very happy doing that, FYI. I'm in the US starting Monday in 2 weeks, but other than that, emails would be very convenient for me because I can always read it, anytime. Phone calls are okay, it's just that there's time difference and I travel a lot, so sometimes when I board planes and then get off, I don't get any messages or any calls. I don't see who was calling. So emails would be perfect for me, or any text messages, anything that has to do with text that I can actually relay to that even later if I cannot do it now.
Great. And Shoshi's email is shoshi@sensoleak.com, everyone. And then we do have a question from Ro Michaels. Ro, great to have you with us. Is there a minimum PSI that is needed for the system to work?
Hello?
Yeah, did you hear that? Shoshi,
No.
is there a minimum PSI that is needed for the system to work?
Not really, as long as it's consistent or as long as we know the ranges.
Okay,
Okay,
good.
it has to do with different systems and different pressures, and it's okay, different even units. Sometimes it's bar, PSI. So as long as we know the transmission rates and what's working, how the operational modes are structured, we can figure it out.
Great. Okay. And Ro, if there's more on that, just chime in. But another question, how long does it take to obtain a pricing bid from you?
About an hour.
Okay.
No, basically, since we don't have a shelf product, it's really all custom made. So the ranges in prices are really big. Depends on what it is. If it's a whole network, a whole desalination plant, or just one water pipeline, it depends. We basically need to sit with the maintenance team or with the decision makers within the company to address all the problems, just to figure out if we can actually provide all the solutions. And that's about it. We will need to know, some structure or how many pipelines there are to monitor, and the pricing will be as fair as possible and would be provided quickly.
Yeah, and from those
Another
implementations that you
question.
have, what is the ROI model for recouping your expenses?
Well, the ROI starts immediately. As clients have reported, their insurance rate goes down immediately because they have this preventive measure. And also, we guarantee there will be no leakages. As long as there's transmission to the SCADA and our system is operational. Also, I guarantee only 5% false alarms, meaning for every 100 times I will tell you there's a leak or a defect or an escalating problem, 95 of them would be definitely what I said. I allow myself 5 times to be wrong. As I said, we had no false alarms so far, but I don't know what could happen in the future, so I'm just leaving some room for error. But I find it hard to believe we would actually have 5 false alarms, because every false alarm that will show itself, we will just train the algorithm to recognize this or to take this into consideration, and it will never ever happen again. The thing is that it's machine learning, it kind of trains itself, but sometimes when statistics or additional models or retraining is needed, we do that. And we divide the pipeline into segments, and we train each segment separately, as well as 2 subsequent segments and 3, so that if even one sensor goes out of work, we will not be not able to monitor anymore. We will have redundancy. So that if, let's say, a pipeline has three sensors, A, B, and C, if we trained it from A to B, from B to C, we will also train it from A to C. So if sensor B is out of work, still we can monitor both segments. And also one thing that the minimal requirement for our system to work is to have pressure and flow. Doing only pressure is basically what everyone else is doing. There's a lot of room for error. The innovation part in our system is that we actually take flow and pressure into consideration together. So flow would be very important to us as well. Yes, Mary?
Yeah, great. Just building on that, that establishing a normalized base, Ro writes, an emerging market system where leakages might already be over 30%. Could you come in there and address
Yeah.
that based on what you just said? Okay.
Yes, we have had yeah, we had a lot of cases actually that they gave us data already containing leakage. In fact, even the one in Netherlands I just showed you already contained very progressive corrosion if it leaked within 3 weeks, right? But once we determine X as the normal behavior, any deviation from that will be considered. It will be very helpful to get a list of like integrity report or a list of prone to leakage locations, or from previous leaks if you have some knowledge about that. So we will be able to fine-tune the algorithm to be even more sensitive in these specific locations, or to recognize leakage, or to recognize normal behavior as already containing a leak, let's say of 10%, 20%, whatever the operator think the leakage, like how big it is. But it's definitely doable.
Perfect.
But then again, if already 30% has leaked, then and this is the norm, the algorithm will be able to recognize a deviation of 30.0001%. Okay, but still the 30 would be the norm.
Yeah.
But it's doable. Everything is applicable and doable. It's okay. We can work with that.
Perfect. Okay, I just want to pause a second because there's some people on the phones who might want to voice a question who don't have the opportunity to chat.
Okay.
Any questions from those on the phones or comments? Okay, I'll come back to you. But you can also feel free to just text me at 312-282-6048 with a question if you are on the phone. And there is another question on, in case sensors are used are not part of the system to begin with, what kind of information would you need to quote a client about the number and types of sensors required?
Oh, it depends. It's like my lawyer always says, don't ever ask a lawyer a question. His answer is, it depends. So my answer is, it depends as well. I don't know which kind of pipeline or what are the needs or what kind of leakages there are. So in order to tell you which kind of sensors you need, I need to know which kind of pipeline this is. And we can help with that. We already done it actually only once in Louisiana when we helped equip a certain pipeline, smaller one, with sensors. We worked with Siemens at a time, but it doesn't matter. We can just recommend, give them several quotes for them to choose. And we will be then connecting directly to the sensors. If there is no SCADA, or hasn't been so far, so there's a solution where we can actually connect to the sensors directly and work with that. So far we had only one case like this.
Yeah, we have a great question here. What is the leakage detection technology that is proposed on Keystone, the pipeline, the Dakota pipeline, for example, and could SensOLeak alleviate concerns for an environmentally sensitive pipe such as Keystone?
Yeah, Keystone XL and Dakota pipelines are definitely two pipelines I'm dying to work with. Unfortunately, they're not very responsive. So if anyone has a connection, I even tried to contact the protesters to present our technology and say that it's not as bad as they think. I mean, if Dakota pipelines or any actually pipelines being built right now, if they have SensOLeak from the get-go, they will never have any problem at all. I mean, anything. Nowadays, I have to deal with, history of the pipeline, previous leakages. I have to learn a lot. If I'm installed, like I installed my system on a pipeline from the beginning, from the the time the pipeline is installed, I believe it will be like a history-changing moment, really.
Yeah, well, that would be wonderful. So everyone heard that here. If you can spread the word and we can relieve the different parties of the concern and show the power of technology, I think that would be a win all the way around. Great question. And one other question. I know the plumbing manufacturers are on the line, and also Suez, leading water entities, Aquamatics. I'm wondering, they're all partnering, or they want to be aware of groups that intersect with their customers, and how do you best establish partners, Shoshi, right now, or should they just add you
In
onto
the
their
water
systems?
industry,
Yes. Uh-huh.
oh, a good question. So far, I have been approaching end users, the operators of the pipeline themselves. I have tried to partner with several engineering companies to have our system kind of embedded in their hardware, in whatever they're trying to um, design for their clients' pipelines and whatnot. It didn't work out because of them, really, not because I did not want to. They thought it would be difficult for them to sell it to their clients. So I'm open to ideas. Any partnership that can bring this technology to be used more will be great, I think. Water, oil, gas, whatever. I'm open to ideas. We can discuss anything. This is
Right.
so easy. It's like what's the word? It could be molded into so many different applications. This algorithm we have, it's even easier to understand than it sounds right now. I'm pretty sure a lot of people are confused, but it's really much easier to have this embedded or installed anywhere, pretty much.
Okay, so in a home, for the plumbers who are working on individual homes and wanting to address or preempt leaks there, it would work there as long as you had the meters at the different places.
I'm
Is
sorry,
that
the question again, you're breaking out.
question? Would it work if you had meters in a home, so that you could modify any leaks or catch
Sure.
them? Good. Okay. And then, have you ever used your
Oh, sure.
technology?
But then again, it's
Go ahead.
hello? Yeah, I just said in municipal or residential networks, it could work perfectly only if there are sensors on each and every line. And there's a lot of branches and a lot of things to take into consideration. So I'm afraid if I suggest this solution to a municipality or a maintenance company, they will tell me it's too much to spend on hardware. So I don't know. It's applicable. It could be doable. It could be done, but only if some money is invested.
Okay. Great. And have you
You
ever
got
used your
another question?
technology for dry gas? Um, does it work for dry
For
gas
drug what?
pipeline? Dry gas?
Dry gas. Oh, yes, yes, anything. Dry gas, liquid, NGL, anything.
Okay. Well, great. I think we had another question on what are you
NOG.
presenting in Australia?
Oh, wow. I'm meeting about 15 different oil and gas, water, and mining companies, and I was actually chosen with two other companies to present to the Prime Minister of Australia during a formal dinner. So all the decision makers in the government will be attending, and probably I would shoot for regulation. This is what I'm trying to get into, the higher layers of say, the decision makers in any country, any market, because if it's mandatory, then no problems with Keystone XL and Dakota and any pipeline if they install this.
Great. Well, I have a special guest, Barbara Higgins, who's the executive director of the Plumbing Manufacturers International, on the line, and she said she'd chime in with some thoughts given their work with leak detection. So, Barb, the
Yeah,
floor is yours.
hi. Thanks, Mary. Thank you for including me in this. This is really great. And my 2 cents worth really is just in support of what's happening here. I appreciate you featuring our graphic that shows the tragedy of these leaks throughout this country and throughout the world. And PMI represents manufacturers of plumbing products that are kind of technologically at the height of their water efficiency. And so we are very concerned and take very seriously the need to address these water leaks as we continue to ratchet down flow rates to save drips of water. It's shocking, as our graphic shows, to know that the trillions of gallons of water, treated water, so very expensive water, is being wasted. So I just have nothing other to add than our moral support that this is really the next natural, logical step in making the most efficient use of water that we can. So certainly applaud the effort, and if there's ways that we can support you, we are pursuing it in a legislative, regulatory fashion, and if there are other ways, letter writing, etc., our members would certainly be behind that. So keep up the good work and the good fight. Thank you.
Yeah, well, thank you, Barb. And Shoshi, you heard it. Barb's a phenomenal resource. But go ahead.
Sheila, if she wants, we can arrange another webinar for her colleagues or partners or whatnot and present the solution. So just they can look into that. One thing I had done in Canada is visit the regulator for about a month every day. They asked me all the questions and they are so eager to pass this as regulation. But in Canada, according to what they said, they need my system to be installed at least in 3 different companies. So,
and great minds think alike. That's exactly where my mind was going. We have, and we can speak offline or email offline, we have 2 opportunities in the springtime, a fly-in to Washington, D.C. in April and a fly-in to Sacramento, California in May. And then our fall conference will be held in Sonoma wine country. So if dealing with plumbing manufacturers isn't enough incentive, perhaps the location in wine country would be. But there may be an opportunity for you to address our groups there. But working through Mary, we'll get those dates to you and see if there are some synergies there.
Okay, great, thanks. Also, FYI, everyone who's listening, I know how difficult it is and how much a barrier it is when there's a foreign vendor or a foreign technology. So I'm opening in 2 weeks a subsidiary in Texas, as well as an office in California, because we started working with the Californian government. So don't worry about logistics or procurement. It's going to be okay.
Yeah, great. Well, Shoshi, we're so excited to have this time from you. And if you could go to, it sounds like
There's
you've
another
covered
question here. Yeah.
everything. Any
oh
other?
yeah, I've actually started something in India, Mr. Rajat, and I'll be visiting probably May. Yes, desperately. Okay. Do you have all the emails of the participants? Oh, here I have one.
I do, I believe. I think everyone, if you haven't registered, please email Shoshi or myself, shoshi@sensoleak.com. But if you could go to the next slide too, Shoshi. We just want to let people know, all of these resources, case studies are on the SensOLeak site. There's also the American Waterworks Association has done an extensive work on water loss control. And we have the Safe Plumbing Group, which is Barb, who she just mentioned, her resources and their legislative support. And then also Swan Forum, and I noticed that says swanforum.org, but it probably should be swanforum.com, is a resource. They just started yes, if you could change that to .com as long as you're editing right there, Shoshi. And if you're wondering how she gets all of this work done, it's by doing things on the fly, just like she is right now. So just a pleasure to meet with a data analyst who gets it, who understands it's all about being digital, being quick, and addressing the need at the point in time, preferably before the point of time, as SensOLeak is doing. So spread the word. You guys heard it first here, or you're one of the first to know about her technology, which is just taking off, and it's taking off so quickly. This webinar is not about selling, but just making sure that you are all in the know. Anything else anyone wants to add? The mics are open, or I haven't muted anyone. And Shoshi, anything further?
No, just very grateful for everyone allocating their time and listening. And those who left, I hope they enjoyed whatever they heard. And let's just think of collaboration. Let's just bring good solutions and good technologies to the world. It's all of our problem, water. It's not just a specific country or a specific region, it's everyone. And if we educate people, it will make a change. It's my belief. It's our life. It's the life of our children and longevity. So let's invest everything we can in water. I'll be happy to discuss everything with everyone, just not next week when I'm in Australia mingling with the president of Australia and Israel. But other than that, I'm available and open for ideas. Please don't be shy. Please keep in touch. And thank you
very
so
much
much, Mary,
the
for
presentation.
organizing all of that.
Yes, thank you.
Sure, thanks.
Thanks, Jennifer.
It's great.
Really great. So have a great day. Hey, next slide, Shoshi. Next slide. You can move to one more.
Yeah, just a second. Yeah, there you go.
Okay.
Happy Valentine's
Hey, everyone.
Day.
You're all sweet water workers. We appreciate it. And have a great Valentine's Day. Thanks to our sweetheart of water, Shoshi, for persevering on this. We'll get the word out to the Dakota and
Thank you, everybody.
the pipelines. Yep. Take care. Bye-bye.
Okay, bye-bye, everyone. Have a lovely day.